And this is math homework for 6-year-olds. And it's about whether or not vertices have a size, which are not true for a rectangle. Choose all of the correct answers. So we have to look for false statements. It has 5 vertices. That is a false statement, so that is not true. It is a closed shape. Queso? Yes. But it is a closed shape. Obviously, this computer screen is a rectangle, so it's already a closed shape. It has vertices that are different sizes. Now, when I read that, I saw this yesterday. Yeah, I saw this like last night, and I was like, I wonder if this would be good to react to on stream. Because we need to look at more math videos. I'm serious when I say that. And I have this other video saved about the most classic 1 = 2 proof. I think this will help get my brain pumping. So, my daughter's first geometry homework in 1st grade asks this question. Doing fine, thank you for asking. Which are not true for the rectangle, and the vertices are different sizes. If they have different angles? No, that's what I thought. When I saw that, I was like, maybe it's talking about the size of the angles, because vertices are just the points at which angles converge. But I want to see if we can try to rationalize whether or not vertices can be of different sizes.
Grade math homework.
And this is supposed to be for 6-year-olds. I don't remember ever learning anything about the sizes of vertices in 1st grade. I mean, people, I keep seeing videos pop up in my recommendations about the Gen Alpha reading crisis, about 40% of teachers quitting their jobs because Gen Alpha can't read. Why can't Johnny read? Why can't Johnny read? God, that gets old. And maybe this is why. Maybe they're too busy doing math to actually... They're too busy doing this type of math in order to read.
Is for 6-year-olds, so it's got to be simpler than sniffing a math book. Let's see, which are not true for a rectangle? A, it has 5 vertices.
Yeah.
B, it is a closed shape. Or C, it has vertices that are different sizes. Well, obviously, A isn't correct.
A is not right. Rectangles have 4 vertices.
We're supposed to choose all of the correct answers,
yeah.
And this is not correct, since rectangles infamously have 4 vertices.
Yes.
As for B, it is a closed shape, although it...
Yeah, do vertices have side? Crusty mathematician who has studied topology way too much. Well, kiddo, let me tell you about zero-dimension knots. Oh, no.
Surprises me that would be a talking point in 1st grade, so B is correct. And
yeah, B is... Yes, it is a closed shape.
And C, it has vertices that are different sizes.
No, when I read that, I tried to figure out what it actually means, and the only conclusion that I could come up with is that it's talking about an angle.
What does that even mean? I have no idea, so I think it's just B then. Which are not true for a rectangle? B, it is a Wait a minute, they tricked me. What
Wait.
A cruddy way to word this question. Choose all of the correct answers, which are the ones that are not.
Yeah, it's the ones that aren't true.
True. I assume that this phrase is here to emphasize the fact that you might have to pick multiple answers.
Yeah.
But that work was already done with the word are, which are not true. That's plural. And the part about vertices having different sizes, let's be honest, that's a little bit silly.
Yeah.
And OP found that part particularly
are they trying to find out if it's about angles?
confusing. Are they trying to ask about the angles? What does this mean? Do 1st graders even know the word vertices?
No, that's the point that I was trying to make earlier, is like, I don't remember learning about the word vertice or vertex for that matter in 1st grade. At best, maybe 3rd, 4th, 2nd grade at most.
One commenter said that their year 1 son knew what a vertex was.
Really?
So maybe the term is age appropriate. After all, year 1, as I understand it, is the equivalent of Americans' kindergarten.
I guess it depends on where you live.
So that's even earlier than first grade.
No, I don't remember learning the word vertex that early.
This commenter also pointed out the conflict in the wording, how it's kind of confusing to request answers that are both not true and correct.
Well, I figured that out rather quickly. I knew what it was asking.
Of course, the Redditors were on her like bumper stickers on a dog.
It's asking you to choose which ones are false, basically.
Mom's car, since her description of the problem wasn't completely literally flawless. As for these three statements, statement
Yeah, A is one. Yeah, you're supposed to circle A and presumably C.
A is... Oh! Statement A is perfect. Everybody knows what it means. You can look at a rectangle and determine if it has 5 vertices or some other number of them.
Yeah.
And then statement B could be perfect, but again, I'm kind of surprised that first graders are learning about this particular property of rectangles.
I don't know if I don't even remember what we learned in first grade for that matter. I just know we learned addition and subtraction. I think we did multiplication in second grade. I don't remember, but I do know we did that in third grade too.
Thought first grade math was more like which shape is a square.
Yeah, that's what I thought too.
Rather than which figure shows a closed
Oh no, we got we're already doing, so we're doing derivatives in first grade now.
bounded region. And statement C, I think a lot of people took issue with because it doesn't really mean anything.
Yeah.
Saying a rectangle has 5 vertices means something.
Yep.
Rectangles have vertices, so you can count them and check the veracity of the statement. But saying the vertices are different sizes doesn't mean anything. You might as well ask if the vertices have different preferences in free-form jazz music.
Oh, yeah.
So then it's easy enough to say that obviously statement C is not true.
Yeah.
But really, it feels like it'd be better to have a meaningful statement which could actually be checked against a real rectangle. Like the 4 angles of a rectangle have different sizes.
Yeah, that would have been a much better question, which they don't. The primary property of a rectangle that sets it apart from other quadrilaterals or 4-sided shapes is that all of the angles are right angles. And, right? Yeah, all of the angles are right angles.
Or...
That's the primary property of a rectangle.
Well, maybe if we just,
Actually, if you make the vertices bigger, because do we really have to, I understand that we're in the mountains, but do we have to freeze to death?
hard enough, we could say that the vertices do have different sizes. Maybe. The question is a little sloppy, poorly written.
I'm guessing what it could be asking is if you draw a rectangle, but then you decide to make the vertices just 4 large dots.
Yada yada. We can't be getting a first grade question wrong. So to be super careful, let's...
Yeah, that's why they are Oh, wait a minute. Rhodey, you're telling me that... Actually, I can see it in the way that it's spelled. The RCT corresponds with the RGHT because within Indo-European linguistics, specifically with regards to Germanic languages, there's something called Grimm's Law, where certain consonants ended up having their pronunciations changed in the transition from Indo-European to Germanic. And one of those changes was the Indo-European k sound becoming a ch sound, which dicht is how the word right used to be pronounced until the GH went silent and then the I ended up being elongated. Let me guess, what is rect? Is it Latin prefix? I'd imagine that it would be, considering that most of the other prefixes for like, well, no. Most of the prefixes for like triangle, quadrilateral, pentagon, hexagon, the gon shapes, those are all Greek. But is rect Greek for right? At least in terms of an angle? No, I didn't even notice that, Rhodey. You just blew my mind.
do a deeper dive on all 3 statements in this math homework for 6-year-olds. It's a bird. No, it's a plane.
No, it's oh, I get it.
It's first grade math homework.
Oh lord, no. This is reminding me of the scene in The Incredibles 2 where Bob is trying to help Dash with this math homework, and he's all like, why would they change math? Because I remember my mom researching what was known as Common Core mathematics, and she thought it was very absurd.
Start with
And so she related to that scene.
vertices. If A is not true because a rectangle has 4 vertices, well, how do we know that? I mean, what even is a vertice?
It's a point where it's a point at an angle, or it's a point where 2 lines meet at an angle.
Is a vertex of a polygon simply where 2 sides meet? If so,
Technically.
what's a side? Well,
A side is like you have your entree and then you have your sides. That's what a side is.
according to the definitions, the sides are the line segments that connect to form the polygon.
Yeah.
That's simple enough, and since a rectangle has 4 line segments that meet at 4 points, it would seem a rectangle has 4 vertices.
No, you see the different sizes of the vertices. You're now looking at the big picture. Let's say this is a very big vertice and this one's very small, but it's still a rectangle. I'm guessing that's what it's asking.
It's not fun. But then,
When you really stop to think about it now.
we really know, for example, that this is one side. Could it not truthfully be 2 sides?
Technically, this is a thing. I can't remember the technical. It's like a bisector, I think.
That then also meet right here,
Because then that would technically make this a pentagon.
giving a 5th vertex? I suppose from the geometry perspective, that doesn't really make any sense, and since there isn't an angle created here with a measure different from 180 degrees, it certainly doesn't
Because technically, you could infinitely divide this line and make infinite polygons with it.
walk or talk like a vertex. But then again, this is something called a star polygon.
I thought that was called a pentagram.
And this is what normal people would call a star, but mathematicians would not technically call this a star polygon.
Really?
And how many vertices do these shapes have?
Oh, that's actually kind of a trick question. Here, let me move. No, not this. I try to click on my avatar and it clicks on the... Here, let us actually count the vertices, shall we? Let's see, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let me double count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 vertices on this. And there are 10 sides, which makes it a decagon, or a 10-sided shape. But this one... he's actually raising a pretty good point. Would we count like this and these? Why did I say it as these? Would we count these as 2 separate vertices? Or would we count these as 2 vertices, or would we just count them as 1? I'm guessing that's where he's going. Let me put this back real quick.
Well, if anything, certainly this must have more vertices than that, since this looks just like that, but with a lot more junk going on in the middle.
Yeah.
Well, nope, not how it works. This star polygon has 5 vertices.
Is that so?
And
Oh, I think I get it now.
this 5-pointed star has 10 vertices. Check
Oh, I get it.
this out. This is called the trick of the disappearing vertices. Here's a pentagon and 5 triangles. That's 20 vertices total, right? Wrong. Put them together and you can see that it's only 5 vertices. There is this concept of self-intersecting polygons.
Okay, so this is not a vertex because so these are vertices, but this one's not a vertex.
Whose edges cross each other. And for this concept to exist at all, there has to be some understanding that when the edges of a polygon meet, that doesn't necessarily create a vertex.
I mean, if you're thinking about, if you were to translate this into 3 dimensions, you could make it so that one of the lines is just on top of another, and so it wouldn't cross at all.
Looking at a rectangle, obviously this is a vertex where two sides meet because of the change in direction.
Okay.
However, looking at the star polygon, this is only a change in direction if we don't regard this as a single side.
Okay.
Regarding this as a single side of the star polygon, we don't encounter a change in direction until right here.
Until the very
where
top.
we meet another side of the star. So whether or not a shape like this truly has just 5 vertices depends a bit on the context.
This thing is missing the Bermuda shorts of Patrick.
It might be one polygon with 5 sides and 5 vertices, but it could also be 6 polygons mushed together. Either way, the humble rectangle is much simpler and has only 4 vertices. So since A is not true for rectangles, that means it is a correct answer.
Yes.
Next up, B, it is a closed shape. What does that mean? There's certainly some amount of intuitive obviousness here. This shape looks to be open, this one definitely closed.
Yeah.
But there's a lot.
But this, of course, just when you think you have it figured out, there's some sort of 5D chess level of nuance that most even high schoolers aren't going to notice.
Lot more to this story than you might think. And finally,
And now we're going to get into the real purpose of this video.
we arrive at the bizarre statement C. A rectangle has vertices that are different sizes.
Yeah.
And this is the one that caused the most arguments in the original post. Some just expressed surprise at a technical word like vertices being used on a first grade assignment.
Yeah, like I said earlier, we've never used the term, I've never heard the term vertex until after first grade.
And the fact that it would have made a lot more sense for the statement to be about angles.
Yeah.
On the other hand, there's nothing technically wrong about asking if the vertices have different sizes. It's just a surprising question.
Yeah.
One of the important characteristics of rectangles is the one which differentiates them from squares.
Yeah, the square is a rectangle because it has right angles, but the thing that makes a square different from all other quadrilaterals is that I actually forgot the technical term for polygons that all have equal sides and equal angles. Is it a perfect polygon, or was it something else? Because a square would be an example of that, because its sides and its angles are all equal.
Which is a rectangle can have edges that are different sizes. So it could be the purpose of this statement is just to make sure students
You're getting close to the end of January and then February. The last month of summer, yeah.
aren't confusing vertices with sides or edges. Though most people didn't seem to think that was the case.
Yeah, that'll be where spring begins for us.
Indeed, there was a whole lot of arguing.
Yeah.
I think it's a trick question. Vertices don't have
Regular polygons. Yes, that's what it is. Okay.
size. I would bet a lot they mean angles of different sizes. Okay, but
I figured it was regular. It was either regular or it was perfect.
the text referred to vertices, so it's still wrong. The kid needs to evaluate the actual sentence, not intended writing. It's a child's homework, not a
It's not a legal text. Well, it may as well be if you're going to get this heated about it.
legal text. You have to go by what the teacher intended. They will not get bonus points for, actually, being their teacher. The
Can I do that?
kid's college admission committee is not going to see their grade on this.
No
Answer
kidding.
it as written. Yes, I know it's not a legal text, but if
But it is a legal text because I said so.
they assume vertice to mean angle or any other concept, they're essentially changing the proposition. I'm not saying the teacher should be precise, but they need to be.
Well, here's the thing. The teacher isn't necessarily the one that might be administering this test or this thing. They could be getting it from a textbook, and the people that make the textbooks would be the ones that have to, clarify.
Clear. Well said. A lot of people see
And this is actually something that my biology teacher once brought up. I remember her talking about how the textbooks don't necessarily tell you everything that you should know about a certain topic. So she had a habit of going off the book, but she still technically had to go with whatever the book says because that's how they would have been tested.
seem to state the intended meaning of the question as if it's obvious. It means that the angles in the vertices are different sizes, or vertices should actually be edges. And then this guy said that this isn't actually homework for a 6-year-old. So
They're at a special school for super smart kids.
I guess OP's in luck.
I don't know.
It turns out that their 6-year-old doesn't actually have this math homework.
Wait.
Because this guy said so.
Okay, so we're taking this other guy's word for it.
Really, I think I agree with this guy. Why is everyone trying to recontextualize the question? It says size.
It says size and it means size.
Means size. It says vertices. It probably means vertices. Do the vertices of a rectangle have different sizes? No.
No.
But we should consider it from several perspectives just to make sure we're not missing anything. In
Yeah.
classical Euclidean
Oh, here we go.
geometry, one of the axioms is that
The whole is greater than its part.
the whole is greater than the part.
Well, yeah.
If we have a line segment, for example, certainly the size of the whole segment is greater than the size of some part
Yes.
of the line. A point, on the other hand, like a rectangle
It's just a part of that rectangle, but
X
it's
is-
not the rectangle.
defined to be that which has no parts.
It has no
and this
parts.
makes pretty clear the intuitive sense
It is a part, technically.
that a vertex has no size.
Yeah.
Or we might say it has a size of 0. If
Oh, okay, I see.
it had any size,
Right. We use, like, these dots just for visual reference. A point obviously has no size, but we still use it for that purpose.
other than 0, then it could have some smaller part, just like the line segment that's smaller than it. And we know that a vertex can have no part. Then, since every vertex has size 0, clearly the vertices of a rectangle do not have different sizes.
Yep.
We could also take a graph theory perspective. In a polygon, the only thing that makes these vertices special is that there are places where two sides meet. However, they're all still just points, and each side of a polygon is made up of infinitely many points. In graph theory, the vertices and the sides or edges that join them are very different things. In the field of graph theory, edges cannot exist without vertices because the sole purpose of an edge is to join a pair of vertices.
Oh, okay, I see where he's going with that.
Hence, in graph theory, this edge is just as good as this one.
Oh, yeah.
These two
You prefer your geometry not Euclidean. Thank you very much. Okay.
graphs
Spins on your own axis until they see you on 180 degrees.
are the same. They're each just a pair of vertices joined by an edge.
Yeah.
And in graph theory, the word size refers to the number of edges in a graph.
Okay.
Hence, the size of this graph is 4. The vertices in a graph, though, also get their own special measure called a degree.
Okay, so I'm guessing this is different from the degrees of an angle.
The degree of a vertex is the number of edges it's touching.
Oh, so that has 2 degrees.
The degree of this vertex, then, is 2.
Okay.
In a polygon, a vertex
Okay, so what about that star? What are the degrees of all of its sides? Or its
is just where
vertices?
2
Well, actually, he mentioned that there are only 5 vertices to that one star.
sides meet. End of story. But in graph theory, a vertex may be the meeting point of many different
Yes.
edges. The degree of this vertex now is 3. If we look at a rectangle as a graph, it's what's called a 4 cycle, because it's a cycle consisting of 4 vertices and 4 edges. And the degree of each vertex in this 4 cycle is 2, which again shows that even in this context, the vertices of a rectangle do not have different sizes, or in this case, degree. And I suppose that's enough for me to say, no, the vertices of the rectangle are not different sizes. Since this is not true, it is correct. Except
Wait, oh no.
graph, the vertex set is just a set of objects.
Oh, hell no.
Which are then related in pairs by the edges. What if
Okay.
the 4 objects in the vertex set are graphs of different sizes, and then the edge set joins these 4 graph vertices
Okay, I see.
to form a rectangle, and then each vertex, since it's a graph, has a size, and like we said, the graphs in the vertex set have different sizes, and so then actually the
Yeah. Okay, not quite what I had in mind.
Vertices,
When it
right?
comes to vertices of different sizes, I just figured making the dots bigger.
rectangle could
Okay, I had fun with that, but I had trouble with it at the same time. Here, we'll leave that real quick. If you enjoyed this video, be sure to leave a like and subscribe, and this video was streamed live on both YouTube and Kick. Be sure to check out the VODs for unedited footage as well. Take care.